Okay, so in this question, we are given that the function is holomorphic in an open unit disk, and the condition of the on the function is mod f of z is less than or equal to mod 1 upon mod z raised to 5 by 2. So I will write it on the next page. So that condition mod f z is less than or equal to 1 upon mod z raised to 5 by 2. In such a case, what is the standard trick that we do? Now we know that this 5.5 by 2 is 2.5. And what is the next integer? Uh, the next integer more than 2.5. So that is 3. So I will multiply both the sides by z cube, mod z cube, both the sides. And what happens because of that is that, so let me write it mod z raised to 5 by 2. So this will become mod z cube fz is less than or equal to what? Mod z raised to half. Okay, so now if I take limit on both the sides, what will happen? This limit will be less than or equal to, so I'll go on the next page. So when I take the limit of mod z cube fz, that limit will become less than or equal to limit of mod z raised to half, and this limit is z tending to 0. What is this right hand side limit? The right hand side limit is 0. So this will become less than or equal to 0, but modulus is always greater than or equal to 0. So this will mean that limit of z cube fz will become 0. Now, what is the meaning of this? If I look at this carefully, this is meaning that limit z tending to 0, z minus 0 into z square fz. So I've separated one z outside, and that will be equal to 0. So what does this remind me? This reminds me of a theorem saying that if limit z tending to 0, z minus a into gz, if this is equal to 0, then this is nothing but this is meaning that z equal to a is what? Z equal to a is a removable singularity of gz. So who is working like a gz in this particular problem? Here z square fz is working like gz in this problem. So from this line we conclude that z square fz, so z equal to 0 is a removable singularity of which function? Of the function z square fz. Okay, and if the function has a removable singularity at a point, then this means that the function is bounded in that neighborhood. Okay, is bounded in the neighborhood of 0, right? Now not only that, if it has a removable singularity, so if z square fz has a removable singularity at z equal to 0, this means that this function z square fz is an analytic function, and that analytic function can now be written as some gz, where gz is analytic function, or it's a holomorphic function in that open unit disk, and therefore I can write that fz is equal to gz upon z square. So if fz becomes gz upon z square, what do you see in this particular function? In this function you see that z equal to 0 is a pole of order 2 of which function? Of the function f. So I will try to show this function, how this function looks like. Now just have a look at this. Mod fz is less than or equal to mod 1 upon mod z raised to 5 by 2. If you look at the graphical way, see this is actually a real number, correct? And this modulus of fz is also a real number. Now we all know that z is equal to x plus iy, so mod z is square root of x square plus y square. Okay, so we will see a graphical representation of this inequality so that you will understand how does a function looks, how does a function which satisfies this property should somehow look. So the graph of the function so this is xy plane, and this is the third is that real axis, blue color. So 1 upon x square plus y square should look like this, because that as xy tends to 0, the graph will go to infinity, right? And if I look at the function is less than this particular 1 upon x square plus y square raised to 5 by 2 and its square root. So So this is how the function should look like. So the function is in the red color thing. See, look at this. So this is how the function should look, less than or equal to 1 upon mod z raised to 5 by 2. So this is how we are expecting. I'll just show the function now to you. So if I'll just look at the function, this is the way I expect the function to be. The function is defined on an open unit disk. Now here it is not open unit disk, but it is less than the infinite region, that blue infinite region that was there. Okay. So I hope that now the entire graphical presentation is also understood, and therefore we conclude that what are the correct options for this particular problem. The option B is correct, that z square fz is bounded in a neighborhood of 0 and f also has a pole of order 2. So the options are B and C.